Hello all. Let's start with class 10 application of trigonometry part 3. So in part 2 we have seen 3 sums. Let's go to the last sums, very important sums. We have also recapped in the previous part 2 which are the things primarily we have to see while solving the sums related to application of trigonometry. Let's a quick recap. We see the first thing, the objects are seen, identify the objects. Second, we draw the figure. The third thing, we try to find the two right angle triangles and the relation of the trigonometric ratios, right? Let's start solving question number 13. It's really very important. As observed from a top of a 75-meter high lighthouse, so there is a lighthouse. From the sea level, the angle of depression of two ships are 35 and 45. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. After reading, we have observed that there are two objects. One is a lighthouse and there are two ships. Correct? Let's read again for interpreting the correct figure. As observed from a 75-meter high lighthouse from the sea level. So the person is standing as observed from the top of a 75-meter lighthouse from the sea level. So the person is standing at the top of the sea level and is observing the two ships. Okay, so let's draw a lighthouse quickly. So here we have a lighthouse. So once we interpret the figure, it will be very easy to understand. So let's assume this is a lighthouse. Okay. So here we have assumed that AB is a lighthouse and the distance of the height of the lighthouse is given as 75 meter. So here we can just write lighthouse. Now what else is given, students? It is given that as observed from the top. So here they have not given the height of the person. So when the height of the person is not given, we can just assume that the point A is the same top, everything is the same. If the height is given, then again we have to draw, right? So here point A is the point the person is standing and he's observing from this top to the sea level. So here there is a sea level. Here we can just observe the sea level. Now here the sea level is just like ground level what you draw the sea level. There are two ships. So let's take the first ship as C and one ship as D. There are two ships, so as observed from the top of the lighthouse from the sea level, the angle of depression of two ships are, so the person is standing here, he is observing the two ships and the depressions of angle are 30 degree and 45 degree. So first he is observing the first ship which is at 30 degree and the second is 45 degree. Now one ship is exactly behind the other on the same side. Okay, so we have drawn correctly, both they are on the same side of the lighthouse. Okay, now first ship, it will be 30 degree, the angle of depression. So whenever you have to draw angle of depression or elevation, first you have to draw horizontal level. So first let us draw the horizontal level, okay, which is imaginary. Let's draw that to be AE. Now, obviously when I join, the first line of sight is AB and the other line of sight is AC. So the person is standing at the top, he is looking at the first ship, so one will be AD and AC. Now you be very careful in naming the angle, okay, in naming the angle. So first one is 30 degrees. So obviously the smaller angle here, this will be 30 degree and the bigger angle will be the 45 degree, correct? I hope the first here we can find out the first angle of depression here is 30 degree, that is a smaller angle, that is EAD. EAD will be equal to ADB, as we know that AE is parallel, A is parallel to BD. It will always be parallel to the ground level. So here AD is a line of sight. So EAD and ADB. So here we can say that angle EAD is equals to angle ADB. They are forming alternate angles, that is 30 degree. Similarly, EAC, if you say angle EAC, will also be equals to angle ACB, that will be equal to 45 degree. Sometimes students usually make mistake in predict the angle. Remember, the angle which is closer to the object will always be bigger, right? So here we solution, here we have written AB as a lighthouse, C and D. So here we can just write C and D are the two ships. You can see there are the two ships here, and we have mentioned already the lighthouse. So once you have found out the object figure, now which are the two right angle triangles we find? ABC and ABD. Which is a common side which this triangle ABC, ABD? Obviously AB. Now what are we supposed to find? Find the distance between the two ships. That is CD. So here we need to find out what is CD. Correct? So when you consider right angle triangle, students, ABC tan 45, we will consider. Why? Because this angle 45, this is the given side, this is the required side. So we'll find what is BC. Because CD lies along BD. So we'll find BD, we'll find BC, subtract it to find CD. So let's start. In right triangle, so we'll consider right triangle ABC. So we'll consider tan 45 degrees. So tan 45 will be equals to AB upon BC. Tan 45 is 1. AB we have got 75 upon BC. So from this we got BC equals to 75 meter. Once we have got BC, can we find in consider triangle ABD, BD? So in right triangle ABD. So in right triangle ABD, we'll find what is tan 30 degree because we want to find what is BD. That is AB upon BD. What is tan 30 degree? Here we can say, I'll just continue here. 1 upon root 3 equals to 75 upon BD. So, sorry, BD. So here we got BD equals to 75 root 3. So can we find distance between these two shifts? That is CD equals to BD minus BC. So we have 75 root 3 minus 75. So as you find that this is a irrational number, this is a rational number, you cannot subtract. And root 3 value is not given. So just will take common. And here you can read the answer as it is. And then don't forget to write the final answer. Therefore, distance between the two ships equals to is 75 root 3 minus 1b. I hope you have understood. Let's move to the next one, students. That is question number 15. This is also a very important and interesting sum. Let's go. A straight highway. So there is an highway. It leads to the foot of the tower. So we have a tower. Okay. A man standing at the top of the tower. So there is a tower. You can find there is a highway which is leading to the foot of the tower. A man is standing at the top of the tower. Okay, in the same tower. Observes a car. Okay, at an angle of depression of 30 degrees, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. So here we can find out there is a highway, that is highway is just a horizontal line we will draw, and it is leading to the, there is a highway means a road which is leading to the tower. So tower and a car is there. So let's predict the diagram. So here we have a tower. Okay. So let's draw a tower. And we assume this tower as AB is a tower. Now, the person is standing at the top of the tower. So as the height is not given, we'll assume the point A. Okay. There is a car. So, okay, I'll just draw a little more so I can get that proper. So there is a car. So let's assume the car is C. The car, for C is a point of car, and the person standing is observing this car. Okay. So observing the car from the point A, so we will draw the angle of depression because the person is at the top. So he has to lower his head. So first let us draw for angle of depression the horizontal level so that we don't miss out the diagram, right? So let's draw first the horizontal level. So horizontal level will be from the point A. So let's take for 0 degree so that I draw the straight line, right? So here we will just draw first the ground level and then the horizontal line. So here we can find from the point B to C, this is the ground level. Now from the point A I have to draw, so let me take the horizontal level and the angle of angle of depression we need to draw. So here AC, what is AC? AC is the line of sight, and therefore you get the angle of depression from point A to C, correct? So from point A to C, we get the angle of depression. The angle is given to be, you just see, the angle is found to be 30 degrees. So this angle is 30 degrees. I'll just name this angle as T. So AD is the horizontal line. AC is the line of sight. So we got angle 30 degrees. This horizontal line is very, very important when you draw. So person standing at the top A is observing the car C, angle of depression. Now what is happening? Which is approaching. Now this is a highway, actually BC is the highway. This is the tower. Here we can say this is a highway, which is, so from C it is approaching to the foot of the tower. Now here we can find 6 seconds later the angle of depression of the car is found to be 60 degrees. So what will happen? This car at C, it is approaching to the foot of the tower. So here it is saying it is approaching the foot of the tower with a uniform speed. So the car is going with a very uniform steady speed. The car C is coming closer to the tower. This is the foot of the tower. So let us assume that the point is D. Now the angle of depression is found to be 60 degrees. And here, so I'll just draw the line of sight for drawing the point A remains the same, but the car has approached towards the foot of the tower. So now the angle of depression is found to be 60 degrees from the point A to B. Okay. So here we find out now the angle of depression, that is angle. Okay, I have taken the same point. I'll just mark this as E. So EAD will be now 60 degrees. As you know that AE is parallel to BC, again we can get alternate angles. So EAD will be equals to ADB, and that will be 60 degrees. What is the time taken for the car to reach from C to D? That is 6 seconds, correct? Now we have to find out the time taken by the car to reach the foot of the tower from this point. What is the time? Now from D to B, how much time will be taken? We don't know the time, so let us assume the time taken be T. So I hope the diagram is understood. So let's go for writing the solution. So we have written already the tower and C. We'll just write the let C and D be the positions, be the initial and the final positions of the car, final positions of car, okay, of car. And let us assume let T be the time taken, let T be the time taken for the car to reach from position D to B, from position D to B. So let us take the time T. Now what is actually DC and BD? They are the distance, correct? And here they have given the uniform speed also. Now after we draw the diagram, next thing we identify the two right angle triangles. Right angle triangles ABD and ABC. Again the common side is AB, right? Now here we want to find out the time, so something which is related to BD and DC. What is BD? Actually the distance. What is DC? Distance. BC distance. So we need to calculate distance, and we all know that distance is nothing but speed into time. And here they have given that it is going with a uniform speed, and we require to calculate the time. Okay. So we'll use the science funda. Here we will just mention let x kilometer per hour be the time taken, be the speed of the car. Speed of the car. Let x kilometer per hour be the speed of the car. Okay, that is taken from C to D. Speed of the, or we can say uniform speed of the car, we can just say. Okay, so here we know distance. So if we calculate distance BC will be distance is speed into time. So speed BC is nothing but, okay, first we will calculate distance DC, that will be appropriate. So we know the speed, that is the time taken for D to C 6 seconds. So what will be the distance? That is time into speed. So we'll have 6x. Similarly, let us find out the distance BD. Distance BD is nothing but, students, here again, what is the time taken here? T, we have to find out, and the speed is nothing but x. So we have xt, correct? So we find out distance DC, we find out distance BD. Once we find out the distance, again now we can find out what is T, because we have to find T, right? So let's first consider right angle triangle ABD. So right angle triangle ABD, tan 60 degree equals to opposite, that is AB upon BD. What is tan 60? That is root 3, and AB we need to find out. Okay. Tower AB, the height of the tower is not given, right? Yes, it's not given. So AB is a common side, so we can equate it. So AB upon, we have AB upon your BD, and BD distance is 60. So from this we understand, therefore AB equals to root 3xt. Let us mark this as 1. Now let's consider the second right angle triangle, that is ABC. So tan 30 degree will be equals to AB upon BC. What is tan 30? 1 upon root 3. And AB we already know, so we can substitute here root 3xt. And what is BC? BC is BD plus DC. And what is BD here, students? Xt plus 6x, because DC is given. Here we can just jot down from 1. So from here now we can just cross multiply here, and we can get, if I cross multiply here, I will get xt plus 6x. See here, 1 into xt plus 6x is the binomial, equals to root 3 into root 3, 3xt. So can you see here, x, x, we can take x common here. So we'll get t plus 6 equals to 3xt. So here x and x can cancel, or you can take like terms also. So we have t plus 6 equal to 3t. So can we find out the value of t? We need to end. So this t goes here, 3t minus t will give you 2t. Therefore, t equals to 6 upon 2, that is 3 seconds. So here we can find, therefore, the time taken by the car, to reach foot of tower is 3 seconds. Foot of tower from point D is equals to 3 seconds. I hope you have understood this. Basically, here we are using the sense it is uniform speed, and we need to calculate the distance BD. So distance is under speed into time, and here the time was already given, so it was very easy to find out what is actually here distance, speed into time we have taken. Here also speed into time concept. Took the two right angle triangles, the common side was equated, and we got the time very easily. Okay, let's move to the last sum. Very easy sum. This is the 16th question. The angular elevation of the top of the tower. So again, let's identify the objects. Angle of elevation of the top of the tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower in the same straight line with it are complementary. Prove that the height of the tower is 6 meter. Angle of elevation of the top of the tower from 2 points. So there are 2 points we can find out. Let the points be, for example, A and B. And the angle of elevation. So here, the angle of elevation of the top of the tower from 2 points. So here we have a tower. So let's take the tower to be here. Okay. So I'll take this point as CD. So if the tower is there. Okay. So let's take the tower. Let's take the base level as CD. So if the tower is there, the angle of elevation of the top of the tower from 2 points. So this is the horizontal level. So let's take the 2 points C and B. So this is the tower. Top of the tower is the point C. So angle of elevation from the point A and from the point B. So AC and BC are nothing but the line of sight. So from this 2 angle of elevations we are getting. So angle of elevations of the top of the tower from 2 points, that is A and B, at a distance of 4 meter, 9 meter from the base of the tower. So A will be at the distance of 4 meter, this DA, and B is at the point of 9 meter. So BD is given as actually 9 meter. Are in the same straight line. So D, A, they are collinear, and the angles formed, they are saying they are complementary. This angle, they have not given the angle actually. In all the diagrams you can find they are given angle. They have said that angle A and angle B are complementary. So if I assume this to be theta, so I can say angle B will be 90 minus theta. Correct? Since angle A and B are complementary, and we have to prove that the height of the tower is 6 meters. So let us assume this to be h meter. Correct? I hope this diagram is very perfectly clear. So here when we write with the solution, students, so here we can write that is, since angle A and angle B are complementary, they are actually complementary. So we can write, let angle ACAD equal to theta. Therefore, angle CBD equal to 90 minus theta. Also, we have DA equal to 4 meter and we have DB equal to 9 meter, and we are supposed to find what is H. Now, which are the two right angle triangles we identify? So, right angle triangles are, we all know that in right triangle CDA is one right angle triangle and CDB. So, this is opposite adjacent, again tan wala, so tan theta equals to, we get H upon 4, correct? So here we get tan theta equals H upon 4. So let's keep it as it is, or we can write H equals to 4 tan theta. Let's keep us mark this equation as 1. Let's consider next right angle triangle, that is CDB. So we have again tan of 90 minus theta equals to, we have CD is H. What is DB? DB is 9. And tan of 90 minus theta complementary is cot theta, H upon 9. So this is equation 2. Okay, we can just substitute the value, or we can just, here we can say, this implies H equals to 9 cot theta. I will mark this equation as 2. Okay. Now when we see this both relation, tan and cot are actually complementary to each other. And we are interested to find H. So in this case, what we will do is, we will multiply this equation 1 and 2 rather than substituting, because we are interested to find H. If we substitute here, we will get the value of tan, and we are not interested in angle theta, but we are interested in H, students. So here we will just multiply equation 1 and 2 as it is required by the sum. So when you multiply, we have to do multiplying LHS and LHS. So we get H into H equals to 4 tan theta into 9 cot theta. So here we will get H into H square. 4 9s are 36. Tan into cot is nothing but 1. So H square is 36. Whenever we take square root on both the sides, H value will get us plus or minus 6. We'll consider the positive value. Therefore, height of the tower is 6 meters. As we know, negative value we don't consider. Okay. So here we discarding the negative value. We assume, since height cannot be negative, we can say the height of the tower is 6 meters. So I hope, students, you have understood this particular application of trigonometry sums very thoroughly. You just a practice will make you perfect. Thank you, students.